Hi, everybody. Today is May 6th, and we're going to be solving simple trig equations. Okay, and we're going to do it graphically. So I'm going to show you how to do this with the graphing calculator, and I'm also going to show you this with Desmos. Okay, you're going to need to be able to do this next year with a graphing calculator. So that's why I'm going to show it to you. Okay, so we want to solve the equation sine x is equal to negative 0.65 for okay, and 0 is less than or equal to x less than 2 pi, okay? So we only want to look for solutions with one rotation, right? So 0 to 2 pi, okay? So if you look at it, this is the picture that we're going to look at on our graphing calculator, okay? And this is the line, negative 0.65, this red line right here. So right here is where the solution is, one of them. And there's another one right here. Now, a couple things. I know that sine x is negative, and remember, this is the ratio of y over r, and r is always positive. So this is only going to be negative in that third and fourth quadrant, the bottom two quadrants, because that's where our y is negative, okay? So that means our angle is going to be between pi and 2 pi, and that's why there's two solutions over here, okay, on this side, and there's no solutions over here from 0 to pi, okay? All right, so to set up our window so it looks like this, okay, you would want to press the window button on your calculator. It's the top row, it's the third one over, okay? Take that back. It's the second one over, okay, from the left. And we'd want to press that window button. And we want to set our x min equal to 0, okay? Why? Because we're looking at our x's between 0 and 2 pi. So we want that left side of the screen to be 0. And then we'd want our x max to be 2 pi, because that's the biggest we want to look at, okay? And then we want, then we have x scale, and this really doesn't matter what you set it at. I would probably set it at pi over 2. So that's what I did for this screen right here, is this is 0 and this is 2 pi. So right here, this is pi and this would be pi over 2. So I'm scaling it by pi over 2. Now sine, the highest it gets is 1, and the lowest it gets is -1, okay? Because we've been graphing it a lot, right? The highest the ratio can be is 1, and the lowest it can be is -1, and it's not even bigger than that or any smaller than -1. So I would set my y min equal to -2, a little bit past -1, okay? And I would set my y max at +2, and then the y scale at 1, okay? And that's what I have on this screen right here. So right here is 0, this would be 2, this would be -2, and then I'm scaling it by 1, so there's a tick mark at every 1 unit, okay? And then what we're going to do is we're going to type in our y1 is going to be the left side of this, so sine x, and our y2 is going to be the value of -0.65. And so we're graphing sine x, that's the black curve. And then we're graphing the horizontal line, -0.65, which is this. And then we're going to use intersection to find these two, okay? All right. So you want to write, okay, so when you're solving these, the write up for this, you got to write this up. It's not just about getting the answer, okay? We're solving this equation. So sine of x is equal to -0.65. And then we're going to get, because of this, I know we're going to get two values for our x, okay? So once we get this graph, we're gonna hit second and then calc and then trace, okay, for the calc menu. And then we're gonna select number 5, intersect, okay? So we're gonna get to this screen by pressing second trace, you're gonna get to the calc menu and then you're gonna select the intersect feature, okay? All right, so let's go to our graphing calculators and let's solve this. So from our home screen on our calculator, we're going to press y equals, and then we're going to type in sine of x. And we're going to do this in radians. So just make sure the top of your screen says radians on it, okay? And then our y2 is going to be -0.65. And then you want to press your window, okay? And like I said earlier, we want this x min to be 0. And then our x max to be 2 pi. So 2 times pi. And then our x scale, pi over 2, pi. no real fixed answer to this one, okay? But I would probably do pi over 2, like I said earlier. So pi divided by 2. It won't do a fraction bar on this, okay? And then y min, I said earlier, -2. And then y max 2. And then y scale is 1. That's good. And you don't have to worry about anything else on here, okay? And then let's go ahead and press graph. And there's a sine function, and then the -0.65. So this looks like our screen on our paper, okay? So we got to find this value right here, this x value, because this x value causes the sine function to be this value, -0.65. And then same thing right here, okay? So this is where we go, and we're going to press second trace for the calc menu to access the calc menu, and we're going to select number 5. And then you got to tell it the first curve. So the first curve is sine. And the second curve that we're going to find the intersection of is this horizontal line, y equals -0.65. So press enter, and then the guess. Okay, so you just need to be close to the one you want to find. So I want to find this one on the left side first, okay? And you just want to be close. Whichever one you're closest to on this, it's going to give it to you. So if I was closer to this one, it's going to give me this one. And because I'm closer to this one on the left, it's going to give me this one, okay? And press enter. And there it is. So one of our answers rounded to 3 decimal places would be 3.849, okay? And that's a little bit more than pi, right? Because pi is 3.14 and 3.14. This is pi right here, okay? Right in the middle here, okay? So 3.849 makes sense, right? Okay? So that's just a little bit past 180 degrees, which means it's in the 3rd quadrant, okay? And this is the one that's going to be in the 4th quadrant, okay? All right, so let's go over and get that one. So once again, you have to go through the whole process again, okay? We need to access this calc menu, okay? So to access that, we have to press second, and then the trace button, and then number 5. Okay, and then we can tell we're on y1, which is the sine x curve. You can press enter. And the second curve, we're on the horizontal line, the red one. Press enter. And then we can just get close to that one over here on the right-hand side. And then once we get the guess and we're close to it, we want to press enter, and there we go. So it's 5.756. The 6 will make that that 5 right here a 6. So 5.576, and those are our 2 answers that we'll record. Okay, and that's how you do. That's how you solve these graphically. Okay, I'm gonna also do this with Desmos because I know not everybody has a graphing calculator, and I still want you to be able to do this. Okay, because the ideas are going to be the same. Okay, so I'm gonna stop this, and then we're gonna go to Desmos. Okay, for Desmos, what we're gonna need to do is go to the wrench, and we need to make sure we're in radians. Okay, and then for our x-axis right here, we want to type in 0. Okay, so we want x's between 0 and 2 pi, right? And you have to type pi I for pi. Okay, and then the step that we want, okay, that'd be equivalent to like x scale. We want pi over 2. Okay, and for y min, -2. Whoops, I put 2 negatives. Okay, so -2 to 2. So this is equivalent to setting up the window for the graphing calculator, okay? And then 1, okay? And then what we want to do is we want to type y equals, and then sine of x, and that produces the sine graph, right? And then we want to do a second one, and we want to do y equals -0.65. Okay? And so this is nice about Desmos is it's right here, right? It's going to give you, 3.849, okay? And that's what we got earlier, 3.849. And then right here, this intersection point is 5.576, okay? And it gives it to us automatically, right? We don't have to go to the calc menu, okay? All right, so there's our 2 answers, okay? All right, when x is 3.849, the graph of sine x is -0.65, and the horizontal line is -0.65, okay? All right, guys, so that's it for Desmos. That's really quick on Desmos, huh? Okay, so let's go back to our graphing or paper, and we'll record these 2 answers. Okay, so whether you did this with Desmos or you do it with the graphing calculator, you do need to know how to do this with the graphing calculator, because on the AP exam next year, okay, we won't be able to use Desmos. Okay, so you need to know how to use this with the graphing calculator, and this is one of the particular things that they actually say you need to know how to do. Okay, so this is 3.849. That's one of our answers, right? So x is about that, and then the other one was 5.576. 0.576. Okay, and that's how you solve these graphically. Okay. Okay. Now we're going to do this. What if you don't have a graphing calculator? How do you do these by hand? Okay, and we're going to do that next. Okay. Okay, so for example 2, I want to be able to solve each equation for 0 less than or equal to x less than 2 pi, same as what we just did graphically. Okay, now another way to say this is bracket in interval notation, bracket 0 comma 2 pi parenthesis. So if I say on this interval, right, I could say it like that, and then it means the same thing. Okay. All right, so I want to solve sine x is equal to -1/2, but my x is my angle of rotation. Okay, so you got to remember that. My x is my angle of rotation. Now, the trig ratio for sine is really, it's your y coordinate of your unit circle. So I'm going to do a little xy axis diagram here. Okay, it's the definition of sine is the y coordinate of a circle, right? The y coordinate on the circle divided by the radius. Okay, now that means that this one of these is negative, right? Either the 1 or the 2, and it has to be the 1. So really this is equivalent to -1/2, which is telling me my y is -1 and my r is equal to 2. Okay, now I don't have my x. Okay, but you're going to be able to do this because we're going to use special right triangles. Okay, that we learned when we evaluated trig functions. We're just undoing evaluation basically is what we're doing. Okay, all right, so where is sine going to be negative? Well, it's going to be in this quadrant and this quadrant because those are the only two places that y is going to be negative. So I'm going to draw a diagram, okay, and I'm going to draw one that goes this way, okay, and I know that this y right here, this is my y, that has to be -1, and this r has to be 2, okay? Now, we're going to draw a diagram in this, we're going to draw the right triangle in this quadrant too, because this also could be where it happens. Okay, my y is -1, my r is 2. Okay, because that's my radius, right? And this right here is my x and y point, and this is the radius. It's like what we did again when we evaluated, like what sine of 7 pi over 6 or 8 pi over 6, or well, we never did 8 pi over 6, but like 11 pi over 6 or 5 pi over 6. Okay, all right, so you should recognize these numbers, okay, because we did so many of these. Okay, this one right here is opposite pi over 6, so this angle's pi over 6. Okay, and that would make this side length positive square root of 3, and this side length right here, this x, would have to be negative square root of 3. And okay, because it's a 30, 60, 90 right triangle. Okay, if you have a side length of 1, a length of 1, I know the value is -1, but if you have a side length of 1 and a hypotenuse or radius of 2, this other leg has to be the square root of 3. Okay, so that would mean that this angle right here of the triangle is pi over 6, and this angle opposite the 1 also has to be pi over 6. Okay, now what's our angle of rotation? Okay, and I need to get my red pen, okay, to show you the angles. Just a second, okay? Okay, so what's my angle of rotation? My angle of rotation is this x value. So I'm going to rotate from the positive x-axis, right, because that's angle 0, all the way to here. And my pen is dying. Okay, to here or to here, okay? Let me draw this in better with a better red pen. Okay, so to right here or to right here. Okay, what is this rotation? Okay, well, in pi over 6, this would be 6 pi over 6. I need to go, so right here is 6 pi over 6, right? Because that's pi. I need to go one more pi over 6, right? So one of my answers, one of my exact answers to this equation is x is equal to 7 pi over 6, okay? If I keep going, and if I go all the way around to here, in 6, this would be 12 pi over 6, because that's the same as 2 pi, right? But that's too much rotation, right? from 12 pi over 6, I got to back off. And then what I have to back off of is this pi over 6. So another answer is 11 pi over 6. And these are the two answers to this problem. Okay, so the two angles that will give you a ratio of -1/2 is the angle 7 pi over 6 or 11 pi over 6. Okay, all right, and that's really how you do it. So I walked this kind of slowly through this one. Okay, but that's really how you do it. Okay, we got to remember. Okay, I'm going to write this up here. Okay, the special right triangles. Okay. Okay, so if this is pi over 6, the side that's opposite that is 1. Here's my right angle right here. And then the hypotenuse would have to always be 2. And this would have to be the square root of 3. And this angle up here is pi over 3. Because remember, opposite pi over 3 is the square root of 3. And opposite 1 is pi over 6. Okay? And then the other one we need to remember for this is 1 square root of 2. Okay? So here's our right angle. This is pi over 4. This one's pi over 4, and this is 1, and this is 1, and this is the square root of 2. I'm going to talk about this a little bit later because it's not going to, the ratios aren't going to come to us like 1 over the square root of 2, okay? And I'll talk about that in a minute, okay? All right, let's go to part B, okay? So to get the hang of this, you got to do, a few questions, okay? So cosine of x is 1 over 2, okay? Now, this is a positive ratio, right? And the cosine ratio is your x over your r. So this is telling me my x has to be positive 1 and my r has to be 2, okay? So I'm going to draw a diagram where this will be true, okay? So where would x be positive 1, okay? Well, it's either here in the first quadrant or here in the fourth quadrant, okay? So that means, I'm going to draw my diagram a little bit bigger. Okay, so that means I'm either in the first quadrant, and from this I know my x is 1 right here and my r is 2, or I could be down here and x is 1 and r is 2. Okay, if x is 1 and r is 2, then this vertical leg right here would have to be the square root of 3. This one would have to be square root of 3, but we're going down, so it's negative square root of 3. And this angle that's opposite square root of 3 is pi over 3. And opposite square root of 3 is pi over 3, right? Okay, so what's my angle of rotation though, right? Okay, so I'm counting by thirds. So this is 0 pi over 3. This would be 3 pi over 3. And then this would have to be 6 pi over 3. Now, why is this 3 pi over 3? Because that's the same as pi, right? And why is this one 6 pi over 3? Because that's the same as 2 pi, right? Okay, so the rotation, I'd have to rotate to this terminal side right here, and that would be only an angle of pi over 3, or I'd have to keep rotating around and get to this one, okay? So okay, so what if I go to here, that's pi over 3. So let's go ahead and write that answer. Okay, so x is equal to pi over 3, comma, or I could rotate all the way around to 6 pi over 3, but that's too much rotation, right? I rotated too much. I got to back off how much? A pi over 3. So that would mean this angle of rotation to get to here would be 6 pi over 3 minus this pi over 3, which would just be simply 5 pi over 3. And that's our other answer. Okay, so this is going to happen in the first quadrant and the fourth quadrant because cosine is positive in those first two, in the first quadrant and the fourth quadrant. We cannot draw it in these two because over in these two, x is negative, and that would have given us a negative ratio. Okay, all right, let's go to C. Okay, so for this one, tan x is equal to 1 over the square root of 3. Now, this is a positive ratio, right? And I know that the definition of tangent is your y over your x, okay? So the way for this to be positive is they're both positive, like what we have right now, or An alternative is this could be -1 over negative square root of 3, okay? So either x is a square root of 3 or it's a negative square root of 3, or y is 1 or it's -1, right? And these have to go together, okay? So what that means is, I'm going to draw a big diagram here. Okay, to get this positive ratio, either they're both positive or they're both negative, right? So where are they both positive? Where are x and y both positive? Well, it's right here in the first quadrant, okay? So this is my y and this is my x. So from this, I know my y is 1 and I know my x is the square root of 3. And we should recognize this. Oh, if this leg is 1 and this leg is square root of 3, the radius or hypotenuse needs to be 2. It has to be 2, okay? Now, where can these both be negative? They could both be negative down here in the third quadrant. So I'm going to draw a triangle there. And remember, we always draw these triangles to the x-axis, not to the y-axis. You'd be doing it wrong if you're doing that, okay? Because then you'd have a different angle of rotation. Okay, so in this case, our y is -1 and our x is negative square root of 3, which would give me a positive ratio, right? Because negative divided by negative is positive. And then this radius or hypotenuse has to be 2. Okay, so this is a 30, 60, 90 right triangle. Okay, so what angle is opposite the 1? It's always pi over 6. So this angle right here is pi over 6. Okay, so right here, our reference angle right here, it's opposite this 1, which is, again, it's pi over 6. Okay, so what's our angle of rotation? Well, because our reference angle is pi over 6, we're going to count by 6, right? And so this would be 6 pi over 6 over here, right? Okay, so our rotation would be here to this terminal side right here, or it could keep going and we could also get the same answer if we rotate into the third quadrant, right? Okay, so what's our answers to this? So our answers to this equation would be pi over 6, that would be this rotation. Or if we keep going, this is 6 pi over 6, and that's not enough rotation, right? We got to go a little bit more. How much more do we need to go? Another pi over 6. So 7 pi over 6. And there's our two answers to this, okay? There are two answers, two angles in which the ratio is 1 over the square root of 3. It's at an angle of pi over 6 and also at an angle of 7 pi over 6, okay? All right, let's go to D. Okay, and you guys, you please email me questions, send me remind questions. If you need to get on Zoom with me, I'll get on Zoom with you and I'll walk you through this if you need help. Okay, anything I can do to help you. Okay, just you got to let me know. You have to reach out. You have to be responsible and just reach out and ask me questions. Okay. Okay, so this right here is not a ratio, right? But I could rewrite this as a ratio. Okay, so this is equal to -1 over 1. Okay, and I know the numerator is the one that has to be negative. Why? Because cosine is the ratio of x over r, and r is always positive. Okay, so I need to draw a diagram in which x is -1 and r is equal to 1. Okay, so where is that going to happen? So we're going to draw a diagram, okay? So x and r, there's no way, x is a leg of a right triangle and r is a leg or a hypotenuse, right? So x is a leg and r is there is no way they can both be 1, okay? You can't have a triangle, okay? So we're not going to be able to draw a triangle for this one. So we have to think, okay, where could x be -1 and r be 1, okay? So it could, since we can't draw a triangle, okay, we can't draw a special right triangle because there's no ratio of x over r that would give you -1 over 1 for any of our special right triangles. We have to look at these quadrants, okay? So hopefully we did enough of these where this works, right? Okay, where we understand this a little bit better, okay? So right here at angle 0, I know my x is 1 and my y is 0, and for this whole diagram, r is going to be 1, okay? So it can't be that. the ratio of x over r would be 1 over 1. That would be positive 1, right? Okay, right here, my x would be 0 and my y would be 1. That would give me a ratio of x over r as 0 because it'd be 0 over the radius, which is 1, right? 0 over 1 is 0. And then over here, x is negative 1 and y is 0 and r is 1. That's it right there, right? So that's it. There's only going to be one answer to this where cosine of x is equal to negative 1, okay? And then this one would be where x is 0 and y would be negative 1, okay? All right, so the only answer to this one is we would have to rotate over here to the negative x axis, okay? That's the only place where our x will be negative 1 and our r will be 1. It's the only place, okay? So the answer to this would be x is equal to, well, what's that angle right there? That's angle pi, okay? And that's how we do these, okay? Now, I'm going to talk about, in the next page, we're going to talk about some problems where the ratio has been simplified and we need to unsimplify it, okay? And so that's what we're going to do next, all right? Okay, so we have to recognize special right triangles, okay? And we don't have special right triangles where we have one side being square root of 2 and another side being 2, okay? That's because this came from a simplified version of one of our ratios for special right triangles. So we have to recognize that this is equivalent to 1 over the square root of 2. So if you ever got the ratio of 1 over square root of 2, I had you simplify it, right? And I had you simplify it, and it became the square root of 2 over 2. So hopefully you did that enough that's just automatically, oh yeah, that's 1 over the square root of 2, okay? And that's one of the reasons I had you simplify your ratios, okay? So you start to recognize, oh, this isn't sides of a special right triangle, but when I unsimplify it, I get sides of a right triangle, right? Because on a 45, 45, 90, one of the sides is 1 and one of the sides is square root of 2, okay? Same thing here, square root of 3 over 3. This actually came from 1 over the square root of 3. And that comes from a 30, 60, 90. One of the sides is 1 and another side is the square root of 3, okay? You can't have a special right triangle where one of the sides is square root of 3 and another one is 3, okay? That just doesn't happen, okay? This one came from 2 over the square root of 3. Okay, because to simplify this, when we got this ratio, we multiplied top and bottom by the square root of 3, and we got 2 square roots of 3 over 3, right? Which is this one, okay? So we don't have any special right triangles where we have a side length of 2 square roots of 3 or a side length of 3. We don't have any, okay? There's only 2 of them, and that's it, okay? So this came from 2 over the square root of 3. Oh, those are side lengths of a right triangle, okay, or a special right triangle, okay? So that's what I want you to recognize, okay? Okay, so here's some more examples. It's going to be really the same thing we were doing just a minute ago, but it's with these with the simplified versions of the ratios, okay? All right, so for example number 3A, okay, what we have to recognize is that this is really 1 over the square root of 2, or negative 1 over the square root of 2. Now, why do I know the negative goes with the numerator? Because the cosine ratio is x over r. R is going to be square root of 2. That's also our hypotenuse, right? And our leg is going to be negative 1. Okay, so I'm going to draw a diagram where that would be true. Okay, so in our diagram, our x is negative 1. So the only place that x is going to be negative 1 is this side right here, right? Okay, and so the radius of square root of 2, those are different. So it's not right here like that last problem I did, okay? We're going to have to draw a special right triangle. Okay, and we're going to draw one down here too, because cosine ratio is negative in this second quadrant and this third quadrant, okay? So for both these, I know x is negative 1, and I know my r is the square root of 2. I'm going to write this negative 1 once right there, okay? And this would be the square root of 2, okay? And now from this, I know if this leg is 1 and the hypotenuse is square root of 2, this other leg has to be, the length of it is 1. Because of the direction we're going, that's positive 1. Down here, this length is negative, or the length is 1. We're going down, so the value of it's going to be negative 1. My angle right here is pi over 4 and pi over 4, okay? So my reference angles are with fourths, right? So that means this angle right here is 4, grab the wrong pen, 4 pi over 4. So what's this angle right here? That's going to be one of my angles. If I keep going, I'm going to go to right here. So there's going to be two answers to this, okay? So the answer to this would be x is equal to, now if I rotate all the way to here, that's 4 pi over 4. That's too much rotation for this first answer, right? I got to back up a pi over 4. So that would be 3 pi over 4. And if I go to 4 pi over 4, I need to go a little bit more to get the second answer, right? I need to go one more pi over 4. So my answers are 3 pi over 4 and 5 pi over 4. Okay? And this has a lot to do with evaluating. If you did the evaluating right, okay, in the last unit, then this is starting to make sense because it's just the reverse of it, okay? All right, so this one right here, we have a ratio and it's negative and it's not one we recognize, okay, because this has been simplified. Okay, so this is really -1 over the square root of 3. Okay, now there's another version of this, right? Because I don't know which one's the negative, because remember the tan ratio is y over x. So it's the y that could be negative and the x be positive, or it could be the y that's positive and then the x would be negative, right? So both of these would produce this ratio right here, okay? So that means, where is tan going to be negative? Okay, so tan's going to be negative where either the y or the x are opposite signs. Okay, so it's not going to be this first quadrant. It's not, or it could be this quadrant, right? And why could it be this quadrant? Because your x is negative and your y is positive. Okay, so let's draw a terminal side in that second quadrant. Okay, so that would be one of the angles of rotation. I'm going to drop to the x-axis to make my triangle. Could it be in this quadrant? Could my terminal side of my angle be in this quadrant? And the answer is no, because in this quadrant, x and y are both negative. And if they're both negative, that would give us a ratio that's positive. Our ratio is negative. What about in this fourth quadrant? Okay, so in this fourth quadrant, x is positive, y is negative. Yeah, that would give me a ratio that's negative, okay, of y over x, okay? So I'm going to draw my other terminal side in this quadrant. I'm going to draw to the x-axis, okay? So I know, okay, my y is either going to be 1 or -1. So this is the vertical piece, the vertical side of my right triangle is the y, right? Okay, so this is going to be 1, or this one is -1 because I'm going down, okay? And I also know that this one right here, this horizontal leg right here is my x, okay? So in this case, my x would have to be negative square root of 3. Okay, because these are my x's right here. Okay, this one right here would have to be positive square root of 3. Well, if you have a leg that's 1 and another leg that's square root of 3, that would mean the hypotenuse or radius has to be 2. Okay, so what's our angle, or our reference angle, I should say? Our reference angle for this triangle opposite the 1 would be pi over 6, because pi over 6 is always opposite 1. Over here, the reference angle is pi over 6. Since our reference angle is pi over 6, that means we want to count by 6, right? By pi over 6. So this angle right here would be 6 pi over 6. And if we go over here, this would be 12 pi over 6. And that's going to help us to figure out our angle of rotation, okay? So if we want to rotate to right here, okay, going to here would be 6 pi over 6, and that's too much rotation. I'd have to back off a pi over 6. So one of my answers is going to be 5 pi over 6, comma, okay, if I keep going with this all the way to here, okay, to figure out what that angle of rotation is, I need to go all the way to 12 pi over 6 and then back up pi over 6, right? So that would be 11 pi over 6. And those are the two answers for this. Okay, a lot of times we'll get two answers. Not always, but a lot of times we will get two answers. Okay, all right, so let's go to the next problem. Okay, so this one we have secant x is 2 squared 3 over 3. Okay, so this isn't recognizable as sides of a right triangle. That's because this has been simplified, right? And so this is actually 2 over the square root of 3. Because if you take 2 over square root of 3 and you multiply by square root of 3 over square root of 3, that's how you get this 2 squared 3 over 3. Now this should make sense. You've seen special right triangles where one of the sides is 2 and one of the sides is square root of 3, okay? Okay. So secant is the reciprocal of cosine, okay? And cosine is x over r. So this is r over x, right? Okay. So if r over x, where would that ratio be positive? Well, r is always positive. So it's going to only be drawn where x is positive. Okay. So where is x positive? Well, x is positive in this first quadrant. Okay. It wouldn't be, we're not going to draw it in this quadrant because x is negative in this quadrant. We're not going to draw it in this quadrant because x is negative in that quadrant. We're going to draw it in this quadrant. So it's going to be these two quadrants. Okay. All right, so I'm going to draw my terminal side in this first quadrant, and I'm going to draw a terminal side in this fourth quadrant. And when I draw it in the fourth quadrant, I'm going to come up to the x-axis. That's not the best right triangle, but you got the picture, okay? These diagrams don't have to be, okay, you should have the labels right, okay? But they don't have to be drawn accurately, okay? Like this is a little bit off, right? These should be the same size, okay? So I know my r from this is 2. This is my r right here. My hypotenuse is r, okay? And I know my x is the square root of 3. So this is the square root of 3, okay? Now, if this leg is square root of 3 and the hypotenuse is 2, this vertical leg has to be 1. And down here, the vertical leg would have to be -1 because I'm going down. What angle is always opposite 1? And it's pi over 6, right? So the reference angle of this triangle is pi over 6 for both of these, okay? What's the angle of rotation? Well, we're counting by 6, right? So this would be 6 pi over 6. This would be, I never write this one because it's 0, okay? If we go all the way around, this would be 12 pi over 6 because that's 2 pi, right? Okay, so what's the angle that we have to rotate? Well, we're going to have to rotate to right here, which would just be the same as the reference angle, pi over 6, or we'd have to rotate to right here, okay? So one of our angles is pi over 6, okay? This one, we'd have to figure this one out, this angle of rotation, we'd have to go all the way to 12 pi over 6 and back off a pi over 6. So that would be 11 pi over 6. Okay? And these two angles would give you that trig ratio for secant. Okay? Okay, last one. Okay? Cosine x is equal to 0. Okay. Now, when this is 0, okay, cosine is x over r. The only way for this to be 0 is if x is 0 and r is some number other than 0. So we're going to call it 1. The simplest version would be 1, okay? So we have to think about where is x 0 and the radius 1. Okay, so where is x equal to 0 and the radius be 1? Would it be right here? No, x wouldn't be 0 there. X would be 0 right here on the positive y-axis, okay? And because that coordinate right there would be, x would be 0, y would be 1, and y would be 1 if our radius is 1, okay? If we keep going, x is not 0 here, okay? And x is not 0, or x would be 0 here, right? On the negative x-axis, or negative y-axis. I'm saying the wrong thing, sorry. On the negative y-axis, x would be 0 there, right? So x would be 0, and if radius is 1, the y would be -1. So and then we're back to here, right? So these are the only two places where this could happen. Well, what is this angle right here? Okay, well, going all the way to here is pi, right? So this would be, have to break up pi into two equal angles, right? So this has to be pi over 2. So that means this is 2 pi over 2, and this would be 4 pi over 2, which means this angle would have to be 3 pi over 2, right? Okay, so we'd have to rotate here to pi over 2 or rotate to here, which is 3 pi over 2. So the two answers for this would be x is equal to pi over 2 or 3 pi over 2. Okay, and there's our two answers to cosine of x being 0. Okay, there's two angles that you put into cosine that would give you a ratio of 0, and it's pi over 2 and 3 pi over 2. Okay? All right, you guys. So that's it for solving trig functions for today. Okay? They're going to be simple ones, right? And they're all going to be ratios. We don't give you, this just doesn't happen, okay? We're not going to give you a ratio that doesn't give you sides of a special right triangle. We're not going to give you one. Nobody does this, okay? We're not going to give you one that that will not have sides of a right triangle or special right triangle, or you get it from landing on the x-axis or the y-axis like we did on this one, okay? All right, you're either going to land on one of these axes, or it's going to give you, put you in a quadrant where you know the sides of one of these special right triangles. Those are the only ones we do, okay? This is special right triangles, okay? And those are used a lot in calculus. So let me tell you, you need to be able to do this for calculus, okay? That's why we need to keep doing these assignments, all right? If it didn't matter, I'd say, like, if it didn't matter, I would say, okay, we're okay for the year. But we need to be able to do some of these skills I'm showing you over these next few weeks. We need to do calculus, all right? Okay, I want to make that really clear. You need to do the assignments if you want to take calculus, okay? Because you got to be able to do this stuff, okay? If you don't want to do calculus, all right, okay? All right, like what I sent you guys the message, okay? And I get that. I probably would be in the same boat, okay? If I didn't need it, why do it, okay? All right, so I'm probably gonna have a Zoom meeting with you guys in the next few days. I will send you a message out just so we can verify that you know. I wanna make sure that you guys know how to evaluate trig functions. That's an important thing, okay? In the last 2 units, like, can you find tan of 7 pi over 6, okay? And then can you find cosine x, can you solve cosine of x is equal to negative 1 over 2. Okay, can you do those? All right. All right. All right, you guys take care. I'm going to put the assignment sheet up and I'll show you that next. So today what I want you to be able to do is I want you to solve simple trig equations. I want you to be able to use graphically and also using special right triangles. And I want you to do worksheet GTF7. Okay. All right, that's it for today, guys. You guys take care. Bye.